Hey guys, so welcome back to your next topic in Catalyst Concepts. So previously we looked at what are the different definitions that we can use, and that is what are atoms, what are elements, what are molecules, and what are compounds, right? So just to recap, an atom is the smallest indivisible particle that we have, and it makes up all matter that we see anywhere around us. Now, atoms can combine with each other, and when they do combine with the same type of atom, we say it's making a something called a molecule. And if they combine with an atom of a different type, then we say it's called making a compound, right? And we also learn about what is an element, right? An element would basically exhibit a property uh, of the atom that we are talking about. Now, element can be a single atom or it can be a molecule of that atom. Okay, for example, oxygen element is basically two oxygen atoms combined to form an oxygen molecule, whereas iron metal, that element of iron is just like a single atom. Right? It just varies depending on which substance you're talking about. So now, elements have certain names. We have heard these names like carbon, nitrogen, oxygen, to name a few. So overall, there are about I think 117 elements that have been identified in the universe. Of those, most of them are natural, and some of them are man-made. Okay, like they are synthesized in the laboratory. Okay, each element will vary from each other because they're made of different types of atoms. So yes, elements will also have different properties, right? Because iron does not behave the same way as oxygen. It's very clear. So now, there is a way of us giving names to all of these elements, right? But why do we have to name an element? Simple thing is, elements are universal, right? It doesn't matter if we live in India or if you live in Antarctica or if you live in like on the moon. It doesn't really matter. The point is, the same elements that you'll find here you're going to find even over there, right? So since they're universal, we need a common name for everything, right? A common way to address something. For example, say that we have iron, and someone across the world has a different name for that same iron. In Hindi, it's called something loha, we call it. Maybe in German, it's called something else. So, in general discussion, we can talk about it. It would still give us confusion, right? Because I say something and the German says something else, for example. But when we're studying something, we need to make sure that we are all talking about the same thing. So, for the sake of the study, what we did is we gave common names for an element. Okay, for example, oxygen is something that is given to an atom of oxygen, right? It basically atomic number 8, what we learn about. Now, whenever you say the word oxygen to anyone who has studied science, they'll know exactly what atom or what element you're talking about. Okay, so study becomes very easy if we have a unified name for everything. That is a major reasoning behind naming the elements in a certain way. Right, some have origins in different languages, some have Latin, some have Greek. We'll not get into all of that discussion now, but basically just know that the names of elements are important to know, because no matter what level of science you study, your elements are going to be addressed by the same names that you learn over here. Okay, now one thing that I would suggest you is, out of all these 117 elements, I'd suggest learn the names of the first 20 elements. Okay, the first 20 elements, you can Google it if you want. Just learn the names of them in order. It will come handy later. Why? When it comes, you'll realize that, yeah, I learned it back then. It will help me now. Now, I'm going to list some names of elements for you. The common ones is oxygen. There is something called chlorine. There's something like sodium, right? And then I can also say potassium. I can also say helium, which is a gas, right? Now, mm, these different elements have different names. Now, we have learned that different atoms combine to form a different compounds, right? For example, if I talk about, let's say, sodium plus chlorine, okay? Sodium plus chlorine. These are two different atoms. If they combine, they will give us something called sodium chloride. Okay. It's a complicated name, maybe, but it's actually a very simple thing. It's something we use every day in our life. Okay. If you can guess it, great for you. All right. Now, this is again universal. It doesn't matter which sodium you use, it doesn't matter where you get the chlorine from. If you combine these two atoms, these two elements, they are going to form sodium chloride only, right? Now whenever we write this down, it's a little lengthy for me to write sodium and chlorine combined gives us sodium chloride, right? So what scientists did is, for each element they have assigned something called a symbol. So there is a symbol for each element. Now again, this is just to make our work easy. What this symbol does is it shortens this reaction that we wrote just now. So what you saw above is an example of a chemical reaction. To make it simple, I can simply write it as symbols. Okay, so I will say something plus something gives. So this is the symbol for gives and what it gives. Okay, in these blank spaces you will get the symbols for whatever element you're talking about or whatever atom you're talking about. So now it's important to know what are the symbols for some common atoms and common elements and why they're named. So there are certain rules when you're naming a symbol or giving a symbol to an element. The first and foremost rule is it can only have one or two alphabets. Okay. It may be one alphabet, it may be two alphabets. Okay. Not more than two. Just either one, if not one, then two. That's it. All right. So, simple example for this would be carbon, which is like a single alphabet, and helium, which is two alphabets. Okay. Now, there is another rule to naming that says first alphabet always small. Okay. Oh, sorry, always large. I'm sorry, what am I saying? My mistake, not my bad. I was talking about second alphabet. So, first always big or capital, and second is always small. Okay. So if I see in carbon, I put the C as capital, right? It's not a small c. In helium, when I wrote H capital and E small. Okay. And typically we use the first alphabet of the name to name it. Okay. So usually start with first alphabet is first. Okay, like for example, carbon starts with a C, so I'll use C. Helium starts with H, so I start it with H. Okay, but I have added N. Okay, now you may ask me, why did we add that E? Why not just leave it at H? Right? It's a very simple answer, because there's something else also that might start with the name H, no? So for example, hydrogen, the first element. Hydrogen also starts with a H, and the symbol for hydrogen was given as capital H. That is why we cannot give the same H to helium. So we add the second alphabet in its name also to it, and we make sure it is small. Okay, so these are the main three cardinal rules when it comes to naming elements. Only one or two alphabets. The first one is capital, second one is small, and typically first alphabet of the name will be the first alphabet of the element. Okay, now there are certain exceptions to this, or let me call special cases. Okay, for example, sodium, you'd expect sodium symbol to be S or something like SO or something like that, right? But both of these are wrong. The symbol for sodium is capital N and small a, Na. Okay, which if you see, neither of these alphabets are there in sodium. Okay, which is weird, right? It's not actually that weird. The reasoning is, does not come from this name. It comes from a Latin name for the same element. Okay. Now, sodium is also called natrium. Natrium, natrium. So the N and the A came as the symbol for sodium. Okay. And not just N, because nitrogen is N. Again, same thing. All right. Also, one more way would be chlorine. Okay. So chlorine, you'd expect either C or CH, right? Both of them are wrong. C is carbon, so we cannot use that. And we don't even use CH. Okay. We actually have the Cl for chlorine. So it's not necessary that once you use the first alphabet, you have to use the second one. You can use any other alphabet also. Not that it is up to us, but it has already been decided. Okay, so no matter who says chlorine, we write the symbol as Cl. Okay, so the second alphabet may be any alphabet in the name, not just the second alphabet. Cool. So these are certain things. A couple more examples for this exception would be over here I have written potassium, right? So potassium symbol is K, capital K. Now again, as you guess, the name the name does not have K. It comes from the Latin name, which is Kalium, Kalium. So the capital K comes from there. Sodium we've already discussed, Na. Chlorine is Cl. Oxygen is O, and helium is He. Right? Quite simple. Now, since I know these alphabets, I can simply write the equation as I want. I'll write it as Na plus Cl and gives rise to whatever. Sodium chloride is NaCl. How we know what NaCl is, that will come to, and we'll come across all of that later. For now, just know that whenever we name, these three rules have to be followed. Meaning, if I write the element name as say small a, small l, then it is wrong. I can never write an element name like this, because it goes again the first rule. First alphabet has to be capital. right? This is not capital, so this would be wrong. Same way, I cannot write A capital L also, because this is not the first alphabet, no, second alphabet. So this is also wrong. If I had to write it, I would write it small, capital A, small a. Okay, and this is correct, and this is actually the symbol for aluminium. Okay, which is again a lightweight metal. Cool. So you should be able to distinguish between what is the could be an element's name and what could not be a symbol, right? So if I give you some examples of symbols, you should be able to tell whether they are elements or they are not elements. Okay. So I'm going to make a small box here, and you can like guess if they are elements or no. Small p. I'll put a capital A. I'll put A5, and I'll put MK. Okay, tell me if any of these could be element names, symbols, and if you think, tell me in the comment section below. You can just drop a comment that yes, this one is a could be an element. Okay, not that it has to be, but should follow the rules that we just studied. All right. Okay. So please do this exercise and the first 20 elements. It will be helpful for you. That's it for now. If you have any questions, doubts, you can drop them in the comments below. And I'm going to see you in the next class. Thank you very much.